Good day everyone. So the Sumeru puzzles were leaked, and I think what we'll do is I will solve all of them for you guys today. So when you go to Sumeru, you can get those freemogems way faster and get the new characters way faster than everyone else. So let's just see. So the first puzzle here is just the definition of a derivative, so there's nothing to solve. It's just the forward differences, so you can just go ahead and open that puzzle. Pretty easy, one primogem. Now let's go to the second puzzle, and I see immediately here that the devs themselves didn't complete the puzzle, so the first half here is a bit weird, but the second half is pretty easy. So what's the derivative of a sum of two functions? Well, that's just the sum of the derivatives. Pretty simple. I think the devs will also sleep here. They probably meant the d over dx of c, in other words the derivative of a constant, and we all know that's just zero. Pretty simple. And then finally, the derivative of a constant multiplied by the variable of interest is just a constant itself. So again, pretty simple, two easy primogems for all of you. Don't tell anyone else about it, but it's kind of cool. So now we get to the funky stuff. So the third puzzle here is basically an application of the techniques we used to solve the previous puzzle. So here we can see the function is x squared times ln of x, and how do we take the derivative? Well, that's kind of easy. You take the first one, you differentiate it, and you just keep the second one, and then you swap it around. So now it's the first one multiplied by the derivative of the second, and we all know that the derivative of x squared is just 2x, and of course ln x is just 1 over x. Pretty basic. So what we do now is we just sort of cancel out, we refactor, and there we go. There's our solution. But I must just warn you guys that right here in the beginning, do include the fact that x must be strictly greater than 0. It's always good to specify a domain because this thing is not differentiable everywhere. Right, so now let us go to the final puzzle, and here we can see a bit of a funky trick, and I think this is a trick question because I don't think this puzzle is actually equal to 1 over pi, but let's try and solve this. So let's just quickly get our beautiful, whoops, not paint side, just paint, we don't want to draw anything. So let's just see if we can't tackle this. So how do you tackle a puzzle? Well, we've got the limit, so we can see at the bottom this is just 0 minus 0, and at the top this would be 0, so effectively this is like a L'Hopital sort of situation that we've got. So to do that, we need to take the derivative of the bottom, which is pretty easy. It's just b minus e once you sort of plug in the 0 into cos of x, but the top here is going to be very tricky. So how do we tackle something like this? Well, there are two sort of approaches. The first approach is to really use the power of the fundamental theorem of calculus. So if you guys don't know what the fundamental theorem is, it basically says if you've got something like this, and you've got so whoops, let me just quickly rewrite it. If you've got something like this, you want to take the derivative of a function with a variable, you've got this, then all you need to do is just simply evaluate the function at the value. So in this case, what we need to do is we can just take the function, in this case the t squared over the square root of a plus 2t to a 5. We evaluate this at the value of 0, and then we can see that, okay, the actual value here is just going to be 0 over the square root of a plus 0. So the answer to all of this is in fact 0. So if we had to sort of differentiate all of this, and we had to use sort of L'Hopital's rule, we would see that the actual answer to our previous, or like our big question here, is going to be 0 over b minus sort of e, and that of course is 0. So no, the answer is not 1 over pi, the answer is actually 0, and that is how you solve this tricky question. Just for a bit of a simple fact, I do not think that you can actually integrate this. I'll probably have to check it out afterwards, but yeah, that is how you solve tricky puzzles like this. So Sumeru, easy, done. I can't wait for Fontaine and the rest of it, so we can actually start doing stuff like Lebesgue integration theory and all the cool stuff. Cheers.